Technologies Private Limited extend a warm welcome to all our guests at this webinar named From Models to Multiples Unlocking Profitable Manufacturing with Stratasys Origin Two 3D Printer. It's our privilege to conduct this session in association with our esteemed partner Stratasys, which will be conducted by Mr. Abhishek Kalra, Associate Vice President Technical at Altem. With a decade of experience in product design and digital manufacturing solutions, Mr. Kalra heads the technical department here at Altem. In this session, we will be highlighting how Stratasys Origin 2 is revolutionizing traditional manufacturing and learn how to transition from tooling to tool-less production and achieve injection molded quality without the mold. It will be beneficial for product designers, manufacturing engineers, and or operating leaders, and will help them unlock the next gen of economics of additive manufacturing. Over to you, Mr. Kalra.
Hi Gaurang, thank you so much for the kind introduction. And for those of us who are joining live and for those who might be watching this later, we have a very interesting session planned for you today, which shows how additive manufacturing, which has been traditionally considered as only a prototyping tool, can be used to create real production parts, not just in the performance of the parts, but also in the quantities that you can produce it. So before I start the session, I'll actually like to show you something, which is a full batch of production part that we have printed. And what you see here, and I'll show it to you a little later in the presentation also, is hundreds of small parts which were made in a matter of few hours. And the performance of these parts, both in terms of physical performance as well as mechanical and electrical performance, matches an injection molded part. So let's jump into the presentation, and if there are any questions, you can leave them in the comments, and me and my team will try our level best to answer it. All right. So um, so typically, 3D printing or additive manufacturing has always been considered as a prototyping tool. What that means is that product designers or product engineers, before they start thinking about manufacturing and while they are still in their design iteration stage, would use 3D printing to build prototypes of these parts, concept replicas of these parts, and essentially they will look at it, analyze the look, feel, and to some extent the performance of the part, and then take a decision whether to go into molds or not. So, for example, there is a product design company which wants to manufacture a mouse, which, as we all know, is a combination of multiple parts, as you can see. Um, it's very expensive and very time prohibitive to make a mold, and then something goes wrong in that mold, and then they come back to do the design development. So that's what the benefit of 3D printing used to be. In fact, close to 10 years ago, it used to be more famous by the name of rapid prototyping. But the industry's demand is changing, and it's changing in a few different ways. First, mass customization is the key, which means that customers are demanding uh, a variety of products, and the pressure of developing faster and bringing your product faster to the market is more than it was ever before. Second thing is that a lot of applications have emerged which cannot justify the cost of tooling. So there are applications which would require customers to build 20,000 parts or 30,000 parts or even 50,000 parts, which might be prohibitive for tooling, because the cost of making a tool and the time of making a tool runs into lakhs of rupees, sometimes tens of lakhs of rupees, and can go up to 6 to 8 weeks. So what do you do in a scenario where you want to roll out those first 50,000 products, test the market, or you have a short volume order that you would like to fulfill? Uh, you would like to have the same quality of parts that eventually would come out of an injection mold, because your pre-batch or your short order has to still represent the same level of functionality and the same level of quality that an injection molded part does, but it has to be also fast and cost efficient. So that's where Stratasys launched close to 5 years ago a very revolutionary technology called programmable photopolymerization, or P3. Uh, and today, on its second generation of the machine, P3 is the fastest way to put high volume of precision engineering parts on the table. We can get to building hundreds, in some extent even thousands of parts per day, and go from mold to multiple, right? So engineers, designers, and manufacturers now have a choice of building very complex parts without doing any tooling, without doing any complex engineering, and without spending a lot of money, and in the quantities that exactly they desire. So if your customer orders 300 parts, you can build 300 parts, uh, and it doesn't matter whether you build 20 parts or 300 or 3000, the cost per part is going to remain. So before we jump into what the machine does and how the technology works and what are some of the benefits of using a technology like this and how cost effective is it to use, a little bit introduction about us. Altem has been a full stack end-to-end engineering services provider since the last 15 years. We are in our 15th year of operation, and over the course of the last 15 years we have joined hands with multiple global OEMs to help customers like you go from art to part, from concept to final manufacturing. Uh, on We have solutions which enable customers to do complete design development, to analysis, to reverse engineering, and then 3D printing in polymers, metals. And now this year we have taken next step to get into automation, where we are providing our customers with robotics and automation solutions. The names that you see on the screen are some of the global leaders in these technologies. One of them is Stratasys, which is one of the companies that essentially invented 3D printing and is leading the revolution of taking 3D printing from a concept stage prototype technology to a full scale production grade technology. Thousands of customers are using this technology across India. Some of them are large automotive and aerospace OEMs. Some of them are small startups. Some of them are medical device companies, and some of them are research institutions. The name is on your screen, as you can see it. Also, we are about 70 people spread across 7 to 8 locations, and very happily serving 1,000 customers, with our head office being in Bangalore. So, what you see on the screen is a production job executed by one of the public sector entities, where they required a very simple clip. But the challenge here was that traditional manufacturing technologies would prohibit to build the 500 parts that they needed. So the challenge was to build 500 such parts, because this was to be going in some repair operation, and nobody was ready to deliver. It was not physically possible to deliver such numbers from a mold, and in a lead time of about 2 to 3 days. So, using the Stratasys Origin machine, we were able to print 500 quantities, and so this it's not so very clear in the image, but one part is a combination of three sub-assemblies in a matter of 3 days and get it delivered to the site. And these parts are running in the machinery for close to 2 years, and they perform just as equivalent to the injection molded part. P3 is also the only 3D one of the only 3D printing technologies, only apart from FDM, also from Stratasys, where parts don't lose physical, mechanical, thermal, or electrical properties, essentially any characteristics property over the life of the part. So once a component is built and it is uh, it, it it doesn't change itself, which is a very common problem with 3D printing, something that has been prohibiting the use of this technology in production. So today we're gonna learn about how the technology works and how different is it from different types of 3D printing technology on an overview level. What are some of the key benefits, and more importantly, what are some of the best fit applications? Now, with the Origin, we are aiming to solve uh, three major problems that manufacturers are looking for. First is the ability to produce ultra high accuracy parts, but also in a repeatable fashion. Production can only work when every part is the same as the other part. And whether you print a part today, or 10 days later, or a year later, or whether you print one quantity or 10,000 quantity, or whether you print on one machine or in five machines, every part has to be the same. uh, Typically 3D printing has had the challenge of being very good when you're printing once of parts, but the moment when you try to scale things, you see challenges. Even though it could be as low as a 50 micron or 100 micron difference, that can lead to a critical component not being suitable for production. Second is a wide variety of high performance yet cost effective material. So Stratasys has been in the business of building 3D printers for 35 years, and Stratasys realizes that one company alone cannot fulfill the need of thousands and millions of engineers who are looking for different types of materials. And just to give you some perspective, there are close to 70,000 known used polymers and composite materials that are used in day-to-day industry, from basic materials like ABS, polycarbonate, to high performance materials like PEEK or Altem. And no one company can build all of these materials. So Origin is an open material ecosystem platform which allows you to take materials from some of the largest uh, material development companies of the world, such as Somos, BASF, Henkel, uh, Evonik, etc., as well as use third party materials which might be of interest to you. And the third thing, which is very important, is in a compelling economics, which allows you to take the decision of building a parts in 3D printing as opposed to going to injection molding, because you get the same quality, same properties, and more importantly, the same cost or similar cost and time benefits that you get with traditional manufacturing. I will play a short video which just gives you a basic overview of the machine.
Introducing Origin 2 3D printing solution, where repeatability meets unmatched accuracy, a true injection molding alternative for economically viable low-volume production. One printer, infinite applications, every industry. Stratasys Origin 2, precision manufacturing, redefined.
All right, so that gives you a little bit of a gist of how the technology works. Essentially, as many of you may know, resin 3D printing or DLP 3D printing. So, the programmable photopolymerization methodology is an addition or an upgrade to the typical standard DLP. And for those of you who know DLP or not, DLP printers are great because they can produce very good looking parts, but they are generally suitable only for prototyping because A, it is slow. It's generally a fast technology, but it is slow as compared to what the industry expects or calls as production standards. Second, the number of raw materials are very limited to basic materials because DLPs are typically low cost processes. And third, uh, a lack of repeatability. So it's great for prototyping, but not so good for production. And number four is parts changing physical mechanical properties over time. So you measure a DLP part today, it'll be, let's say, with an accuracy of 50 microns, and 3 months later, because of the atmosphere itself, it would have warped or deformed. Origin allows to essentially take the benefit of a DLP process, which is using resin material to produce high surface finish parts. But due to its process control and heat control inside the chamber, Origin allows customers to build parts in 50 plus different types of materials that are known today, which includes materials which have temperature capabilities of close to 400 degrees centigrade, ceramic infused materials, carbon fiber based materials, as well as give injection molded quality close to 50 micron accuracy and close to 3 micron uh, resolution. What we do different as compared to traditional DLP systems or traditional SLA systems is build a lot of process control, which is what Stratasys is famous for. So we could make the chamber of the printing absolutely inert, which allows us to build uh, parts with much more sensitive materials, could log potential for non-acrylic chemistries. So those of you who know DLP, people are only able to use acrylic-based materials. We can control the chamber process and the bed chamber. That means we can heat up the build chamber in which the parts are printing to a level that we want, as well as we can gradually increase or create a temperature gradient. We can manipulate exposure time, that is what is the duration of the time on which the image is being projected onto the resin, and we can manipulate uh, the delay settings in the software, and we have a lot of sensors inbuilt which essentially measure the complete properties of the chamber and uh, make sure that every layer is printed perfectly so that the next layer is printed perfectly, and so on, and so forth. So using this process we can create parts with surface finish of close to 3 micron RA, which is very close to injection molded finish, as well as we can create very tiny features, very tiny textures, but all the way up to large parts without any type of warpage or not. And we are not just saying this, we have got ISO certifications done on these process. So um, you can access from our website a document which shows repeatability studies of this platform, which allows this platform to build consistent parts across builds, across different positions at the build, and across machines. So whether you print a part on the left corner of the machine and the same part that is printing on the center of another machine, and the third one on the right corner of a third machine, will all measure the same up to 98.5% across build platforms and about 94% across printers. So we are one of the only people in the industry who are able to achieve this level of repeatability, so that when you as customers give 10,000 parts to your customers, you know all the parts are performing well, and they are performing well always. And what we are able to do is to be able to take the benefit of the fact that we can produce injection molded level quantities, is also to give you injection mold level materials. So today in the Origin platform we have close to 40 different materials that are readily available between us, said that is Stratasys, and some of our material suppliers or some of our material partners, such as Henkel, Somos, BASF, which is now called Forward Aim. And you can see on this graph we have some basic materials which are biocompatible in nature, all the way up to this material called 3955 from Henkel, which is a FST approved fire resistant aerospace grade material. We are also launching in this month the world's only and pure true silicon, not silicon like, not silicon mimicking, purely silicon material, which can give you some very interesting results. I'll play a video. uh, you'll start to see that in your screen in just a minute. So we are able to print ultrasonic flexible parts, also biocompatible in nature, which allows you to create things with silicon which are typically very traditionally difficult using injection molding. So if I want to make 20 parts, 50 parts, or even 5,000 parts, I can just stack them on the build platform and start using my parts from the same day or from the next day onwards. Using this, any typical scenario that you might expect in a product or in a process, such as I'm showing an image of a typical factory here, which includes brackets and hinges, hose pipes, adapters and tubes, pulleys and gears, connectors, fasteners, cable management systems, switches and buttons can all be directly 3D printed. We found some key applications, and these applications are typically possible with a wide variety of materials. So if you go on our website, and we'll put links in the description, you will find a list of materials and what properties those materials offer, and more importantly, what materials are they similar to. For example, 3955 is similar to Altem or PBT. And if you talk about stiffness to weight and strength to weight ratio, it can even give you a better performance than aluminium. Not only are we giving Origin gives you access to materials developed by Stratasys, but they also give you access to materials developed by larger third-party suppliers. So we have, it's a very complex slide, but we have, for example, companies like Henkel, we have companies like BASF, we have companies like Forward AM, who are developing tens and up to hundreds of materials, including biocompatible materials, including castable materials, and of course, carbon fiber and fire resistant based materials, which can be used on the platform to build parts in the characteristics that you and your customers want. So we have success stories from aerospace, where we already have FST grade ULV0, that is fire resistant materials, directly available. As well as, if you look at this video from a connectors manufacturer, uh, you can see uh, how precise connectors are manufactured straight out of the origin machine, and they are used directly into the process. And remember, these parts are as strong as it can get, as compared to injection molded plastic or even machined plastic, and parts will last you for the entirety of the life. Now I've been talking about how many that you can build this in very very large volumes. So let's try to quantify the large volume. So I've taken a very simple example of a connector, which is like a very small but very complex geometry, about an inch by inch part. And as you can see, we can fit close to 400 parts in the build plate. And if you are able to see my camera, this is how typically the build plate is going to look like. So you can stack parts on top of each other by putting some minimal supports on the top, and that's how you can utilize the complete build volume, which is a good 400 height of the printer. And if you notice, it is the time taken per part is less than 4 minutes. And the cost per part, of course, cost per part could vary depending upon the material, but using a general purpose high flexibility prototyping material, we are able to build this part in about 12 rupees, sorry, in about 40 rupees. So it's a very compelling economics when you don't have to invest in tool, when you don't have to invest in labor, and when you don't have to wait for 6 weeks for your parts to get ready. Now just imagine, it takes 400 parts in 12 hours approximately. um, so you can build 800 parts per day, or uh, some 12,000 parts, 24,000 parts per month, so on and so forth. So the amount of volumes you can build, and this could also mean that you are replacing your, till the time your injection molds are getting ready, which will give you, of course, tens of lakhs of parts. You can build the first 20,000, 30,000, 50,000 parts on the injection mold. Or you have a customer who is looking for a small order, because maybe they are trying out a new product or a new market, or it's a startup. You can build high precision parts, and every part on the stack will have same level of repeatability. So as you can see from the video, it should be up in your screen if it's not just yet, how these parts are building inside the platform. And um, very beautifully done. Takes about 12 hours, 14 hours ish to finish this job. And at the end of 14 hours, you can have close to 400 parts with you, which are ready for deployment, ready for production. So with that, I come to the end of my short presentation. Uh, Origin is perhaps one of the most fascinating 3D printing technologies that is available in the market today, due to its ability to produce these kind of parts in these kind of volumes. You'll be very happy to know that we have uh, multiple demo machines for, and we invite you guys to come and do trials in our offices. So we have a system in Bangalore and a system in Pune. So if you are interested in learning more about this technology or building your parts, or uh, getting into a project where we understand and analyze the scope of your project with regards to whether this technology fits or not, please feel free to reach out to us, and our regional managers will guide you through the next step forward. Thank you so much for your time. I really appreciate all of you spending this time with us on a Friday afternoon. Uh, that's it from my side. If we have any questions in the chat, I will take them now. Otherwise, we end this session. Thank you so much. Uh,
Yeah,
uh,
I think we have these two questions from Mr. Garam.
okay. Okay. So uh, the questions are, what will be the largest part this printer can print? The bit size of this printer is about 200 by 110 by 400. So the largest part that you can print is 400 tall. And just to give you a perspective, this is the largest build that you can print. I mean, I'll just put this next to it just to give you a perspective of scale. Now you can choose to build an array of smaller parts as we have done in this project, or you can build one large part. It doesn't matter. uh, and we also have a question about materials. So you'll be very excited to know that we have multiple types of um, flexible materials. We have flexible materials in white color, in black color, in translucent color. So if you have to do parts which need to do flow analysis, uh, we have those available as well as we have flexible materials in biocompatible materials, right? And as I said, we are launching the world's first true silicon with sure hardness of 27 for 3D printing. So we have close to 8 different types of flexible materials, as well as we have pure transparent glass like materials, which can give you a transparency of 97%, which replicate PMMA. And we also have transparent materials in biocompatible. So if you're doing a medical device project, we have this. And when I say biocompatible, it is ISO 13485 approved as well as FD approved. Uh, uh, how much time will it take to prepare the build is a question. Typically 15 to 20 minutes. Um, and we have our proprietary software, which is free of cost, which is called GrabCAD Print. Um and You can load any 3D model in it, whether it is a STL file or a SolidWorks model or a CATIA model. And it allows you to create stacking in, I think, depending upon the kind of computer that you have, it could take 15 to 20 minutes, maybe even lesser, to prepare a build. And then that build can directly go to the printer and it prints automatically. Um, I think that's it for the questions as well. Once again, thank you so
Uh,
much for joining. Um, and if there are any more questions which will come on the YouTube comments, we will answer them. And uh, inquiry at altem.com is our email ID. You can also find our numbers on our website. Feel free to get in touch. Thank you so much.